In this video, we'll be introducing you to our data set about cars. Katie will be utilizing R to code some of the visualization and data cleaning for this data set. All the R code for this video series will be available as a link in the description of the videos.
Thanks, Britt. The dataset we used was downloaded from UCI Machine Learning Repository. It is called AutoMPG Dataset. Now let's dive into the variables that are contained in this dataset. Our dataset contains 9 variables, and it's composed as variables such as MPG, which is the miles per gallon, a measure of how far your car can go on 1 gallon of gas. There's also cylinders, which is a central part of an engine where the pistons move. There's displacement, the cumulative volume of all cylinders that is displaced by the pistons as they move up and down, whatever that even means. We have horsepower, which is a measure of power. This is the rate at which work is being done. We have weight, the weight of a vehicle, acceleration, the increase in the rate of speed of the vehicle. We have the year of the vehicle, and the region of origin, which is American, European, or Japanese. And we also have the make and model of the car. I previously described MPG as being a measure of how far a car can go with 1 gallon of gas. For comparison, we'll use 2 cars. We have a big truck. It's a 1970 Ford F-250, and it has an MPG of 10. This means that for every gallon of gas that you put in, you'll be able to go 10 miles, which isn't a lot really. We also have a 1980 Honda Civic, which is a smaller car, and the MPG in this car is 44.6. So for every gallon that you put in, you'll be able to go 44.6 miles. Alright, we're in my favorite part now, the R code. Don't worry about trying to copy down the whole code like Brittany said. We have uploaded the entire script of all the videos into GitHub. You can access them by clicking the URL at the description box. Okay, first things first. You want to set your working directory right here to have the path of where you have the CSV that you're feeding into R and where you want your output to go. So where your data is stored and when you want your output to go into. And you want to read in your data. I know I have a CSV, so I'm going to use the function read.csv, and I know that it's called cars.csv. It has a header, so I'm putting header equals true. And I'm putting NA strings, NA dot strings equals these items, because I know from previously looking at it that whenever it had a missing value, it had either a question mark or it would just have a missing value, like just a blink. So let's go ahead and read this in. And we saved it under cars 0. That's the name of our data set. So we want to look at the names, or just the variable names. And here they are, all 9 of them. We want to look at the head of it, which will give you the first 6 rows. And you can see this is the first car. It goes all the way, and it loops around because my screen is a little bit small. You can also see the dimension, which will tell you the rows and the columns. So it has 398 rows and 9 columns. If you want to look at it sort of how it looks in Excel, you could use View with a capital V and Data Frame. And it'll give you something like this, where you can go side to side, up and down, and you can even sort if you want to sort by weight or cylinders or whatever it is that you want to sort. I like using STR, which is structure, and it'll tell you some of the information we already have. It tells you the number of rows, the number of variables, the name of each data variable, the type or class, and then it'll also tell you the first few entries right here. If you want to look at the min, the maximum, the quartiles, and the median and the mean, you can use summary. And you can see each variable, and it tells you right here, the minimum, the first quartile, the median, the mean, the third quartile, and the max. It also tells you things, for example, here, you can see that horsepower has 6 missing values. It has 6 NAs. And we'll deal with that right now. You can run something like this, which is asking R to give you the median for the horsepower, and it'll give you an NA. And that's because it has some missing values, like we said before. But you would know that already because you ran these sort of things to see the summary statistics and get sort of a hold of what you're even working with. In order to see where the missing variables are, you could run something like this. So if you ever use is.na, it'll give you a vector that tells you where it is false and true that you have an NA. So you're asking R, is there an NA in this? And it will tell you false, 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 but true here. So now something you can do is say which NA, and it'll tell you which rows are missing an entry. So it says that row 33 is missing an entry. Let's go ahead and look at that. We can see that in row 33, if we go down this way, there is an NA value for horsepower. Let's see, how do we get rid of that? So something I like to run is you could do na.emit and you give it the data frame. And so what it will do is it'll emit all the missing values or all the rows that have missing values in your data frame. And you can save that. So now let's run it and save it as cars complete. And let's run dim again, which tells you the dimension, just so you can see the difference. So now we have 392 rows and 9 variables. And in the past, we used to have 398 rows and 9 variables. If we go ahead and run summary once again, we can see that horsepower no longer has missing values. Let's start visualizing now. In this example, I will show you the code focusing on only a few variables. If you want to investigate other variables, it's really easy to change a code to the variables that you're interested in. Essentially, the trick is to change this part right here, right after the $sign, and put the variable that you're interested in. So why would we want to do a histogram? That's the first part. Histograms are a really great way to graphically summarize the distribution of a univariate data set. They will show you the center, the spread, the skewedness, and if there's any outliers or multiple modes in the data. Here's the code. You would put hist, variable interest, and main is the title. So here's the title of the plot I want. Let's go ahead and run that. I usually like adding an AB line to it, or an AB line. I'm doing one where I'm adding the median of the MPG on top of this chart right here. I want it to be blue, and LWD4 is just for style. Here you go. We can also look at box plots. Here's the code for one of them. It says box plot, the variable, which is MPG, and I want it to be by cylinders. And I want all of them to be colored red, and here's the title that I want. Let's go ahead and run that. We also can do it for horsepower and for any other numerical variables that we have. We can do a scatter plot as well. Here's a scatter plot for 2 continuous variables. Scatter plots are pretty great because they show you the relationship between 2 variables. So I have one right here, and we want to see the relationship between horsepower and MPG. And I really like doing something with this. So we have the same exact plot that we just did right here, but now I'm going to add a color, and the color is going to be each cylinder. So cylinders 3, 5, and all the other ones are going to be in a different color now. Let's go ahead and run this. And obviously you don't know which one is each color. So you would add a legend to it. I want my legend to be in the top right, and I want the legends to be called this, which is what the cylinders are called. The colors, I want them to be also those numbers. And this part is also just for style. You can change them. And there it is right there. All right, now let's go ahead and start subsetting our data. I have the code right down here. We want to subset the data by a specific cylinder number. If you run table in a variable name, it will give you a table that says the category, which is 8, 6, 4, 5, and 3, which is a cylinder number, and how many entries we have for each of those. So we can see that for 3-cylinder cars, we only have 4 rows or 4 entries out of the 392 total entries. And we want to subset cylinders by only the largest ends. So I want to take only the 8 cylinders and only the 4 cylinders. And the way we do that is you would do data frame name, and then you want what variable and what you want that variable to equal. So for example, here you have, we want to get all the cylinders, that's say number 4, of the data frame cars complete. And we want to set this as a new data frame that is called subset 4. And we can do the same exact thing for the 8-cylinder cars. If we want to see the dimensions for both of these new data frames, we can run dim, as you've seen before. Now, because I know that the structure of both of these is essentially the same, I will go ahead and R-bind them, which essentially means we're going to paste the 8-cylinder data frame and the bottom of the 4-cylinder data frame. Essentially, we will have now, they go vertically, so it's a longer data frame together. And we can go ahead and see the table now, which should only contain the 4 and 8-cylinder ones. We can run the dimensions, which are now smaller. It used to be 392 and 9 variables, and now we have 302 rows and 9 variables. And we can visualize it. This is the same plot we did before, but now the only numbers that we have are 4 and 8, instead of all of these right here. And that's it. That's how you subset your data. We will now cover how to center your data. You might want to mean center your continuous predictor variable before we move on to linear regression. This will come in handy later as it will help us interpret our beta estimates. The way you do that is you take your predictor variable, which in our case is MPG, and you subtract the mean of the same predictor variable. Let's go ahead and run this. I'm saving that as a variable that I call c.mpg. Now, let's make some plots so you could see the difference of the one before it was centered and after it was centered. As you can see, when you mean center variables, we essentially transform the variable in a way that the resulting variable will have a mean of 0, which is right here.